So hello guys, welcome back to my YouTube channel. In this video, we'll be going through some very nice sums, nice and intriguing questions of maths of course, and yeah, some of them will be of trigonometry, integration, and all those levels of question would be higher than that of school syllabus. Some of the questions I will take will be of IOQM and higher level like IMO, RMO questions. So the first one is of course here. If you want to give it a try, then you can do it by yourself by taking a screenshot or noting this question down. And then if you're having difficulties in this, then you can always resume the video. So I'll be getting out of the frame so that you can take a screenshot or something. So let's start with this question. Is it everything in frame? Okay. So this is cos. Okay. So we're given that sine theta plus sine square theta is equivalent to 1. We have to find the value of this long expression. It's a nice expression. It's like a very long one, but it can be written down as something. So if we take this equation, and I'll just write it down here. We can write this sine square theta as 1 minus cos square theta. 1 minus cos square theta is 1. So from here we can say that sine x plus 1 minus cos squared x equals 1. These 1 and 1s cancel out. So we get sine x equals cos square theta. Because I put this cos square theta on this side, on RHS. So now we got cos square theta as sin x. Now you might notice a type of sequence being formed here, which is everything in this is in terms of cos square theta to a certain power. And we can just ignore this minus 1. We don't have to write it down as negative sine square theta minus negative cos square theta, nothing like that. So we got sin x is equal to cos square theta. Let this be here. This is equation 1. Now we can try to, get this equation 1 into this equation. I'll just name it as equation 2. So here we can see that cos raised to 12x can be written as cos square x to the power 6. Because this 2 and 6 multiply to give us 12. Plus 3 into cos square theta to the power 5. 5 into 2 is nothing but 10. Plus 3 into cos square x to the power 4. 4 into 2 gives us 8. Plus cos square theta to the power 3. Because 3 into 2 gives us 6. And minus 1. We don't write it down as anything. We don't use any identity or whatever. So we know cos square theta is equivalent to sine theta from this equation. So we can just see the substitute sine to the power 6 theta plus 3 sine to the power 5 theta plus 3 sine to the power 4 theta plus sine cube theta minus 1. So we get this new equation. You might notice something here. If we ignore this negative 1, I mean we're not ignoring it, we're not cutting it out or anything. If you just ignore this minus 1 and look at this right here, we can take sine cube x common from here, okay? If I take sine cube x common from here, I get sine cube x plus 3 sine square x plus 3 sine x plus 1. This might be going in a quadratic shape type of thing, but leave it. What is this? This is nothing but sine x plus 1 the whole to the power 3. Now it's very tough to, identify this type of thing, because with more and more practice you will be able to substitute these long of an equation into this. So we get nothing but sine cube x into sin x plus 1 the whole cube minus 1. We got this new equation, and now what do we have to find? We just have to find the value of this. This is nothing but sin to the power. What can this be written as? What can this be written as? Sin x. Oh wait, yes. Sin x into sin x plus 1 the whole to the power 3 minus 1. Am I right? This is nothing but 1. So we get 1 minus 1 equals 0. From here, from this whole equation, from this whole two equation, this big of an equation, we got 0 as the answer. It's not very good of an answer, but it is the answer, so we take it as the answer. Let's go. This was question 1. Now we'll be doing a nice integration question, which I personally liked because I went through that question and it puzzled me a lot. So we'll try that question now. Okay, so let's go on with the integration question now. This one is a very basic level one. So we'll be moving on gradually from basic to medium to advanced level integration questions to very advanced. For me, I have not done very advanced level of integration. I'm not trying to sound very cocky. But yeah, for me, whatever is basic, medium, advanced, we'll be going through all those types of questions. So I'll be getting out of the frame now. So you can take the screenshot of this question, try it by yourself. If you're facing difficulties, then you can always resume the video. Okay, so let's go on with the question. So we have a downward parabola with equation 3 plus 2x minus x square and a line AB which cuts the parabola at point A. The point A has x coordinate of 1.5. So A would be nothing but 1.5 comma y. To find this y, this coordinate is common between this line and this parabola. So if we just plug it into this parabolic equation, we get 3 plus 2 into 1.5 minus 1.5 the whole square. This dot is here. So we get nothing but 6 minus 1.5 the whole square, which is nothing but 3.75. We get 3.75, so we found the coordinates of A. Not that big of a deal. We've only found a coordinate. We've not done the whole question yet. So yeah, we found one limit, which is 1.5, which was already given. So to find the area under this curve, we need the equation of the line AB. How can we find the equation of line AB with just one coordinate? Okay. So to find the equation of the line with just one coordinate, there would be a common gradient for the curve and the line. So at x is equal to 1.5, m, the gradient of it would be the differentiation of y at x is equal to 1.5. So this gives us nothing but 2 plus 2 minus 2x as y dash. So y dash at x is equal to 1.5 would give me minus 1 if we put it here. So we get m as minus 1. We can use the equation y minus y1 equals mx minus x1 for the coordinates, for the equation of the line. So we get y y minus 3.75 equals minus 1, x minus 1.5. We get y equal to minus x plus 1.5 plus 3.75. So we get y equals minus x plus 1.5 plus 3.75, 5.25 minus x plus 5.25. Okay. So we basically just integrate it. We need the coordinates of B, of course. So at B, the value of y is 0. So we get x as 5.25. So the limits would be 5.25 to the x coordinate of a, which is 1.5, of minus x plus 5.25 integration dot dx. This is the area under the whole line, okay? We still have to find the area under the curve. So let's do this step by step. This would be, the integration of this would be nothing but minus x squared by 2 plus 5.25x with the limits 5.25 and 1.5. So if I put this in the calculator, I get 5.25, 1.5 and minus x plus 5.25. The answer is 7.03125. This is the area under the whole line. So you can write this down, or if you solved it and you've managed to solve it, then that's very good. So you can write all this down, and I'll be erasing this so that we can find the area under the curve at those limits. Yes, so let's, okay. This was A's coordinate, okay? So to find this, I'll name it alpha. Alpha is nothing but another value of x. So for this, we need to find the roots of this equation. So minus x squared plus 2x plus 3 would be equal to 0. X squared minus 2x minus 3 is equal to 0. X minus 3, x plus 1 would give me 0. So x is equivalent to 3 and minus 1. We cut this minus 1 without looking at it. Why? Because here the value of x is positive, not negative. So alpha is 3, this is 1.5, we can integrate this, 3, 1.5, and 3 plus 2x minus x squared dot dx. We get, if you want me to integrate, I can do this job. 3x plus x squared upon 2 minus x cube upon 3 with the limits 3, 1.5. So we get 3 plus 2x minus x squared. We get the area as 3.375. Previously, we got the area under the line as something like, what did we get? We got the area as 7.03125 under the whole line. So we do area under line minus area under curve, which is nothing but 7.03125 minus 3.375. So we get 7.03125 minus 3.375. We get the final answer as 3.67. Yes, this is the final answer. Okay, if you solve this, if you manage to solve this, then it's very good because you have your basics all cleared out. So now we'll be moving on to another question, which is of the next question we're about to solve is general mathematics question, and I'll be erasing all of this and writing down the question on the board here. The question you can see on the board is the general maths question. I'll be getting out of the frame now, so you can try this question by yourself. Okay, let's solve this question. It states that root 3 plus x plus root 3 minus x over root 3 plus x minus root 3 minus x gives us 2. So there are two ways of solving this. One way is, just taking this as t, taking this as z. So we get t plus z over t minus z equals 2. So we get t plus z equals 2t minus 2z. T goes here, z comes there, t equals 3z. Substituting t and z, we get root 3 plus x equals 3 times of root 3 minus x. Squaring both sides, 3 plus x equals 9 times 3 minus x, nothing special. 3 plus x gives 27 minus 9x. 10x gives us 24. X is 2.4. This is the long algebraic method. So this basically gives us 2.4. So the next method is componendo and dividendo rule. In this, we take the sums of the denominators and we minus the numerator. This might sound confusing and all. It might sound that I'm speaking Arabic and stuff. But it's a very easy rule. You can use this to save time in your school or exams or whatever. So, all that we do is this. Root 3 minus x minus root 3 minus x over root 3 plus x plus root 3 plus x minus root 3 minus x minus 2. So here we get, if we factor all of this out, we get root 3 plus x minus root 3 minus x over 2 minus, if we rationalize the whole thing, then we get root 3 plus x times squared times root 3 plus x by 2. So we get, from there we get 20x is equivalent to 48. We get, this is equal to some answer alpha. So 20x minus 48 is alpha. 20x minus 48 equals 0. Not alpha actually, because it's a constant. X is equal to 48 by 20. X equals 2.4. You can use these two methods. They're very easy and you can use them in your school exams or whatever.